In 1987, light from an exploding star, Supernova 1987, in a neighboring galaxy, the Large Magellanic Cloud, reached Earth, the closest supernova explosion witnessed in almost 400 years, allowing astronomers to study it in unprecedented detail as it evolves. An international team of astronomers announced that the supernova debris, which has faded over the years, is brightening, and marks the transition from a supernova to a supernova remnant. Supernova 1987 has become the youngest supernova remnant visible to us, said Robert Kirshner of the Harvard-Smithsonian Center for Astrophysics CFA, who leads a long-term study of SN 1987 with NASA's Hubble Space Telescope. Since its launch in 1990, Hubble has provided a continuous record of the changes in SN 1987. Supernova 1987 has become the youngest supernova remnant visible to us, said Robert Kirshner of the Harvard-Smithsonian Center for Astrophysics CFA, who leads a long-term study of SN 1987 with NASA's Hubble Space Telescope. Since its launch in 1990, Hubble has provided a continuous record of the changes in SN 1987. As shown in the image above, SN 1987 is surrounded by a ring of material that blew off the progenitor star thousands of years before it exploded. The ring is about 1 light-year 6 trillion miles across. Inside that ring, the guts of the star are rushing outward in an expanding debris cloud. Most of a supernova's light comes from radioactive decay of elements created in the explosion. As a result, it fades over time. However, the debris from SN 1987 has begun to brighten, suggesting that a new power source is lighting it. It's only possible to see this brightening, because SN 1987 is so close and Hubble has such sharp vision, Kirshner said. The debris of SN 1987 is beginning to impact the surrounding ring, creating powerful shock waves that generate 10 rays observed with NASA's Chandra 10-ray observatory. Those 10 rays are illuminating the supernova debris, and shock heating is making it glow. The same process powers well-known supernova remnants in our galaxy like Cassiopeia A. Because it's so young, the remnant of SN 1987 still shows the history of the last few thousand years of the star's life recorded in the knots and whirls of gas. By studying it further, astronomers may decode that history. Young supernova remnants have personality, Kirshner agreed. Eventually, that history will be lost when the bulk of the expanding stellar debris hits the surrounding ring and shreds it. Until then, SN 1987 continues to offer an unprecedented opportunity to watch a cosmic object change over the course of a human lifetime. Few other objects in the sky evolve on such short time scales. This research appears in a paper in the June 9, 2011 issue of Nature.